Hello, Tensor friends. We've got another problem here. Tensor Calculus problem of the day, posted on 7/20/2026. Okay, here's what we're going to do. We're going to define a function here, a curve, and I chose the helix because it's fun. And on that curve, we're going to put a point. Okay, now that point could be a particle, and it could travel along that function like this, and we could say, what is the velocity and acceleration of that particle? How can we define that? How can we make that a function of time? Well, one of the ways you do that, if you remember from vector, the calculus, is you use a position vector. So we can define a position vector starting from the origin to that particle, and now that position vector becomes a function of time. Whereas the particle, since it's in a coordinate, the system is a function of coordinates and time. So it's a compound argument, right? All right, let's go look at that. So, part A, if the position vector, which we just looked at, which is a function of a coordinate, but that coordinate is a function of time, we have a compound argument here. So use the multivariable chain rule to derive a tensor equation for velocity. Okay? That's part A. Part B, express that velocity that you found of a particle in polar coordinates. So we can do a real example. Part C, using the derived equation for velocity, that's what you derived in part A, now derive a tensor equation for the acceleration of a particle. And there's one more. Part D, use the derived equation from here to express the acceleration in polar coordinates. Okay? So we're going to derive an equation, use an example, derive another equation, and use an example. Okay? And I'll post the answer tomorrow. All right, see you later.